For these questions, we need to sketch a standard bell curve, the normal distribution, and we're going to relate it to a situation with a quarterback. So, the very first thing that we're going to do is draw out that bell curve that I already did, and I'm going to label the mean that goes right down the middle here. That's going to be x bar, and in the problem, the mean is listed as 225, so 225 passing yards. The next step is I'm going to label everything above the mean. So I'm going to label one standard deviation above it. I'm going to do two standard deviations above it. And then I'm going to do three standard deviations above it. So to come up with the actual value that is above, or one standard deviation above the mean, which is 225, is we just add our standard deviation in our problem, which is 48. So 225 plus 48 is going to be 273. That goes right there. And then I add 48 to 273. That gives me 321. And I add another 48 to 321, which is 369. So that gives me three standard deviations above the mean. To get three standard deviations below, I do the same thing, except I'm going to be subtracting values. So my last one is right here. So the values come in now. So I do 225 minus the 48, which is the standard deviation. That gives us 177, I believe. And then if we subtract another 48, we get 129. And then subtract another 48, and that gives us 81. So this would be my entire bell curve, or my normal distribution, labeled with all three standard deviations. Now, as we move a little bit lower, question 11 and 12 are asking for percentages regarding some of the information. So, if I'm dealing with percentages, I'm going to use my three standard given percentages for normal distributions. These three percentages will be broken up to find all the different spots right here. So, like, for example, 68% is the difference between one standard deviation below the mean and one standard deviation above it. This is two standard deviations below it to two standard deviations above it. And then this is from three standard deviations below to three standard deviations above it. So 99.7% of the data goes from negative 3, or not negative 3, but 3 below the mean to all the way up here, which would be three standard deviations above the mean. So if you break up all these different percentages, you're going to get what I get below. So from the mean to one standard deviation above the mean, it's 34%. Same thing with mean to one standard deviation below. And then you have 13.5%. This is 2.35%. And then the space that is above three standard deviations above the mean is going to be 0.15%. Okay, if I write all this down, then that helps me answer these questions below. So it says, what percent of his performance would you expect the QB to throw over 321 yards? So 321 yards is right here. It's two standard deviations above it, and we want the percent that is from there and higher. So the 2% that I have is going to be this one, 2.35% and 0.15%. If we add those two guys together, we're left with 2.5%. That's the percent of his performance that we would expect to go over 321 yards. We're going to do the same thing with question 12, but this time we're looking for the percents between 81 and 273. So 81 is three standard deviations below the mean. I'm going to put a little line there, and we want everything all the way up to 273, which stops about here, which is one standard deviation above it. So we're going to take this percentage, this one, and this one, and add them all together. That gives us 83.85%. That's the chance that his performance will fall between 81 and 273 yards. In this last question, or last situation, we have a lot going on. Lewis is doing a study on basketball players. He asks 50 professional basketball players to shoot the basketball 10 times, and it records how many times that they make that shot. And then he also asks 50 rookies to shoot the basketball 10 times. And again, he records how many times they make that shot. All of that information is reflected in both of these graphs. So, if, for example, in the professionals graph, there was one professional that made 4 shots. Then there was 4 professionals that made 5 shots. And then there was, how many is this? 5 professionals that made 6. There was 4 professionals that made 7, and you get the gist of it. Down here in the rookies, there was only one rookie that made 10 shots. Now that you can understand these charts, let's take a look at the shape, center, and spread. So let's take a look at professionals first. Professionals have a shape that starts off high here, but then it kind of curves down and it straightens out down here. The tail is on the left side, so we're going to call this one left skewed. For the rookies, all that data seems to be in the middle here around 4, 5, and 6, and it curves down right here, and then it curves down right here. So this one is more symmetrical because if you cut it in half, about 50% of your data is on the right and 50% of your data is on the left. So it's pretty symmetrical. It's also shaped like a bell curve. I think I said that. And that's going to be the shape of both of these graphs. Now let's take a look at the center. And I'm going to start with professionals. The center of professionals, well, one might think the center would be somewhere here because you have 4, 5, 6, and 7 over here. Or actually, maybe some people would actually say the center is 7 because it's literally like the middle number. However, you want to write out all your data. So, for example, you have a 4, and then you have 5, 5, 5, 5. That happens 4 times. And then you would have a bunch of sixes. I believe that's 5 6s. So you'd write out 5 6s. And then you have sevens, right? 4 7s. And then you have some eights, a bunch of nines, and then tons of tens. And then once you write those out from least to greatest, you would want to find the middle. So that's going to take me a really long time to write all the nines and the tens. But I think it's safe to say that the center, if we estimate it, is probably going to be heavy to the right side. So that means that the true center of the professionals will probably fall, I'd say, around 9, somewhere like give or take, because there's so much weight pulling that center to this side. So it's literally not the center of this information here, it's the centermost or the median of all that data. When we take a look at the rookies, this one's a little bit easier to see the center because you've got a bunch of data over here, and then this is kind of even over here. The same amount of data is on the left. So the center of all this, you'd probably find to be, I'd say about 5. Maybe it's pulling to the 4 a little bit, but I'd say about 5 would be a good center. And the last thing we're going to talk about is spread. And spread is the like how much that data varies. So for professionals, the lowest amount of shots made was 4 right here, and then let's do that in a different color. So 4 right there, and then the highest amount of shots made were all 10 shots. So we started with 10, and then we went all the way down to 4. So the difference of that was 6, and that's what we would call the range. So the data ranges by about 6 shots. For the rookies, our lowest number of shots made was 1, and then the highest amount of shots made were all 10. So the highest was 10 subtracted by the lowest, which is 1. That range would be about 9. So it looks like the professionals range, vary much less than the rookies, or not even that much less, but the rookies data has a big variety. You know, there's some people that made 1 shot, and then there was one person that made all 10. So that's a big range right there. In our last question, 14, all the way here at the bottom, it's asking, would it be unusual for a professional to only make 2 shots? And I think that would be yes, that would be very unusual because 2 shots right here for the professional. Whoops. 2 shots here for the professional would be at the very bottom part of the distribution, no one was recorded of doing that. So that would be very unusual. Is it possible that a professional could make only two shots? Sure, but it's just very, very unlikely. So that would be definitely unusual.